Hello everybody, welcome to my presentation. I am Hastia Asadi, Scientific Assistant at University Duisburg-Essen, Institute for Metal and Lightweight Structures. In this presentation, I am going to speak about the weathering degradation of PET-PVC fabrics, different layers of PET-PVC materials and different weathering mechanisms of each layer, and finally I will explain you our experiments related to artificial weathering of these materials. PET-PVC fabrics are one common type of architectural coated woven fabrics. It's composed of different layers with different functionalities, but the main functionality of coating layers is to protect PET yarns from different impacts, especially weathering impact. The weathering degradation of this multi-layer composite starts with blistering of the top coating and exfoliation of this. After that, we have gradual disappearance, and then primer and PVC main coat will resist against weathering attack. But with the passage of time, plasticizer might migrate and we have the possibility of aging cracks. In the worst case, when whole coating decompose, we have the possibility also to see unprotected yarns, as you see here. PVC degradation can compose of plasticizer migration, while PET degradation mainly happens because of chain scission of the molecules. The mechanical properties deterioration of PET-PVC fabrics have been evaluated by many scientists, while only a few studies focus on physiochemical changes of this material and the relationship between mechanical properties deterioration and these physiochemical changes. In this experiment, I worked with PET-PVC type 2, 3, both coated and uncoated woven fabrics, but they have a specification as listed here. Type classification is based on tensile strength, and I used uncoated woven fabrics because first of all, there are load carrying elements of this composite, and it is better and easier to trace the physiochemical changes of material under weathering in the molecular structures of woven PET yarns. For axial weathering, I combined impact of UV, temperature, humidity, and also dark cycles to assess the possibility of post-photo degradation. For characterization of material, I used uniaxial tensile testing, FTIR spectroscopy, capillary viscometer, and also yellowness index measurement based on the standards listed here. The most PET yarns are sensitive to photochemical degradation by two mechanisms of Nourish type 1 and Nourish type 2. In both mechanisms, we have chain scission, it means breakage of chemical bonds, and as a main product, in both we have carboxylic acid. For example, in artificial weathering condition 1, combination of UV, temperature, and condensation for PET type 2 by extending weathering time period, molecular weight decreases, tensile strength decreases, while chain scission rate increases. Additionally, we have some more evidences for this chain scission by, for example, the increase in the wavelengths of 1688 belonging to the carboxylic acid, and also the degree of crystallinity decreases, which indirectly shows the possibility of chain scission. As it is shown here, we have discoloration. In the beginning, virgin state is white and then turns to yellow, and this yellowness index measurement also approved this possibility. Sensitivity assessment of both coated and uncoated type 2 and type 3 materials shows that we have a stiffness and tensile strength also here. tensile strengths decrease under different weathering conditions. In these different weathering conditions have a base of photodegradation plus dark cycles to see impact of post-photodegradation and condensation to see impact of hydrolysis. For both stiffness and also tensile strength, as you see here, always we have the decreased minus values when we compared with the two virgin state. We have minus values, yes, which shows that we have always decrease in these two mechanical properties. Weft yarn are more sensitive to warp yarn in both materials, and also in stiffness is not important, but for tensile strength there is a clear decrease of tensile strength for uncoated yarns, which indirectly shows impact of PVC coating. And in the end, by eliminating condensation cycles or dark cycles, tensile strength reduction does not change too much. As a conclusion, I could say by increasing the exposure time, both tensile strength and the molecular weight decreases because of the possibility of chain scission. And we have discoloration in PET yarns, and the main mechanism of mechanical properties changes in investigated material is photodegradation. In the end, I want to acknowledge Mehler Technologies for providing test materials, and also Dr. Klaus Opwitz from this institute for measuring yellowness index. Thank you very much, and if you have any question, you can contact us.